This is one of the harder problems that students have to deal with when they are working with hyperbolas. The reason why is because we're going to have these two coefficients. That's going to make completing the square a little bit different. And you might be asking, why are we completing the square? Because this is in general form. And if we want to be able to identify the parts or graph a hyperbola, we need to be able to convert this into our standard form. That is where all of our formulas and understanding of the parts of the hyperbola come from. So let's go ahead and start converting this to standard form, and then we'll go ahead and find all the good stuff if we want to sketch a graph or whatever may be the case while you're watching this video. So the first thing we're going to do is organize the x's, the y's, and get the 64 over to the other side. Okay. So now that I got everything nice grouped together, and you can see here I only have one y, but here I have two x's, so I'm grouping them together. And the reason why is if you look at the standard form, right, you have a x minus h quantity squared and y minus k quantity squared. So we need to create that. And the way to create that is by completing the square. Before I can get to completing the square, I recognize here that I cannot have a coefficient. So I'm going to have to factor out that 4 before I have to complete the square. Here, I actually already have this as a quantity squared. I don't have a linear term, so this term is actually going to be fine just the way it is. And notice I just subtracted the 4 to the other side. Okay. So now we need to go ahead and complete the square. And notice I factor out that 4, which is going to be very important because when we add our number c, which is going to create our perfect square trinomial, we need, oops, I forgot to subtract that in there. When you factor out a 4, you divide out a 4 from both these terms, and therefore that should be a 10. Be very careful with that. Okay, so now what I need to do is find the value that's going to create a perfect square trinomial inside this parentheses. So you're going to take your middle term, divide it by 2, and then square it. Remember, it's going to be c is equal to b divided by 2, quantity squared. All right, so what is that value? Well, let's take a negative 10 divided by 2 is a negative 5. Negative 5 squared is going to be 25. That is going to be the value that is creating my perfect square trinomial inside this parentheses. Okay, now here's where it comes in the big part. This is why one of these problems is difficult, why students get this wrong all the time. Remember, I factor out this 4. When I added the 25, which is creating my perfect square trinomial in here, I actually added a 25 that's being multiplied by 4. So if I need to create an equation that's going to be equivalent, I have to make sure that one, I add a 25 over here, but also that 25 is being multiplied by 4. Right? This 25 is being multiplied by 4 on the left-hand side. So when I add a 25 on the right-hand side, that one also needs to be multiplied by 4. Now, take a look. 25 times 4 is going to be 100. 100 minus 64 is going to be a 36. The other thing I need to do is go ahead and factor this down. Hopefully recognize when you create perfect square trinomials, that is going to create, it can be factored down, into a binomial squared. All right, so now I almost got it into our standard form, but we're not there yet because our standard form of a hyperbola is equal to 1. Right now we have it equal to 36. So to go from 36 to 1, I don't want to subtract 35, right? What I need to do is I need to go ahead and divide everything by 36. That will make a 1 here on the right-hand side, and that is going to simplify here over on the left-hand side. Now, over here, dividing that 36 into both these terms, 4 over 36 can be reduced to 1 over 9, or you could just say it as x minus 5 squared over 9. And then a 9 over 36 can be reduced to a 1 over 4. Voila. All right, now we have it in what we call our standard form. Now, you might forget what the standard form looks like, but if you look at any textbook or on your notes, the form when you have the x and the y is going to look just, when you have the x first and the y first, or the y second, is going to look like this. Okay, and the reason why this is important is because for the equation of the hyperbola, a squared is always first. It's not the biggest like it is for an ellipse. It's always first. It's always a squared minus b squared. And then x minus h and my k are going to be my center of my hyperbola. And it's also important is that if your x is over your a squared, so in this case, you could swap, right? It could have a y minus k. You could have the y squared first and then x minus 5 over here. If that was the case, you would have your transverse axis would be vertical. That's going to be where your foci and your vertices are going to lie. However, since my x is over my a squared, because remember the a and the b are fixed, since my x is over there, that means giving me my transverse axis is going to be horizontal. But let's first go ahead and recognize what exactly is going to be the center here. Now, technically, I could write this as a y squared. You could also write this as a y y minus 0 squared, right? So therefore, let's go ahead and figure out what the center is going to be. The center is going to be a 5, 0. Okay, the next thing is let's go ahead and identify my a squared and my b squared. So if 9 is representing my a squared, that means my a, let's go and write this over here. So therefore a is going to equal to a 3. If b squared is equal to 4, that means my b is equal to a 2. And the nice thing about hyperbolas is we all remember the Pythagorean theorem, right? A squared plus b squared equals c squared. Well, that relationship is the exact same for hyperbolas. So my a squared plus my b squared, 9 plus 4 is going to be my c squared, so I can say c is going to be the square root of 13. Now, the important thing about understanding your a, b, and c is because that tells you where your vertices are going to be, your co-vertices, as well as going to be your foci. Now remember, my horizontal axis is over my, x is over a, so that my transverse axis is horizontal. So then from my center is going to be left and right is going to be my vertices and my foci. A tells you the distance from your center to your vertices. B tells you the distance from your center to your co-vertices. And C tells you the distance from your center to your foci. So if we have our center, and what we're going to do though is make sure you're going in both directions. Okay, so we're going to add, so basically my vertices are going to be at 5 plus or minus 3, 0, which we can kind of fixate that, right? That's going to be a 8, 0 and a 2, 0. The foci is going to be the exact same thing, right? That's going to be left to right as well, so that's going to be a 5 plus or minus a square root of 13. Oh, I'm sorry, 0. And then last but not least is going to be our co-vertices. Now, the co-vertices is going to be on the conjugate axis, which is going to be vertical. Since my transverse axis is horizontal, the conjugate axis is going to be vertical, and that's going to be 2 plus or up or down. So therefore, for my center, I'm going to go up 2 and down 2. So I'll write it like this. It'll be 5, 0 plus or minus a 2. Which we can write much faster just as 5, 2, as well as a 5, negative 2. All right, so now, I don't know. I decided I just want to do the whole video all together, so let's just go ahead and graph what this thing is going to look like. So we have a center, 5, 0, so we really don't need everything over here. We can kind of go like this. So 1, 2, 3, 4, 5. All right, that is my center. Go there. Vertices are going to be 8, 0 and 2, 0. So 2, 0 and 8, 0. So 5, 6, 7, 8. Our foci is going to be 5 plus or minus square root of 13. Well, crap. What the heck is square root of 13? Well, we know the square root of 9 is going to be 3, and the square root of 16 is going to be 4. So it's going to be between 3 and 4, right? So if you add, like, let's just say 3.5, 1, 2, 3, a little bit more, right? That'd be 1 foci. And then subtract 3, let's say in a decimal, 1, 2, 3, going to be somewhere here. Now, the important thing to recognize about your parabolas, your ellipse, and your hyperbolas is your parabolic always opens up to the foci. So we know that the general direction is going to be outward, right? They always open up towards the foci. But let's go and get our covertices so we can identify where the asymptotes are going to be. So that's going to be 5, 2. And 5, negative 2. Okay, so now all we simply need to do is actually what I'm going to do here is I'm going to create a box of my vertices and my covertices. The reason why I do that is to help me go and identify my asymptotes. I could find the equation of the asymptotes, but unless you need to know them, I wouldn't say to worry about trying to find the linear equation. If you just want to graph it, just use this box, right? And then what you're going to do is just take the point and the diagonal, and you're going to connect them. Then you can see that your parabola is going to approach both of these asymptotes. It's going to look something like that. But again, there is a formula for the asymptotes that you can go ahead and identify. It's in your notes. Plug it in, A and B, and your center, and you're good to go. But hopefully, ladies and gentlemen, this was helpful for you. If you have any more questions, let me know.